Hi. So now let us see this example, and this we have to decompose till third normal form actually. Okay. So let us see here. So here we have a actually total uh, 10 attributes are there in this, and we have many set of FDs are also there. So what we have to do, very first thing is, if anybody told decompose up to third normal form or up to any normal form, the very first thing is we have to find the key. So how you will find the key? So we told one simple thumb rule that RHS side, whichever attributes are not there, you collect them actually. So A is there? No. So attribute A is not there. And B is also not there. And C there, D there, E, F, G, H, I, J. So these two attributes definitely going to become part of key actually, primary key. Okay, so the very first thing is find the closure for these two first of all. So that is what AB closure let us find first. So A and B. Now AB deriving C, note down, and A deriving DE, take it DE, and B deriving F, F deriving GH, and of course D deriving IJ. So if you observe these two attributes deriving all attributes in the relation. So that means key is what actually? So key is A, B. So that is what the first step is done. Then now check that whether it is in a second normal form or not. So you can see that A deriving any other attributes in this? Yes, here this is a full functional dependency, but this is partial functional dependency because part of the primary key, that means prime attribute deriving non-key attributes. And even this is also partial functional dependency because part of the primary key, subset of key deriving non-key attributes. So these two are the uh, uh, partial functional dependencies. Of course, these are full because this is non-key, non-key. So these two you don't need to consider. Now come to these two actually. Consider first A derives DE. A derives DE. So what we have to do from this, find the LHS of closure. So A closure, let us find. So if you find A closure, first of all A. So A deriving DE. So note down DE. And D derives IJ. So is it deriving any other? No, actually. So this is what one relation we are going to make it. And next, another partial dependency, let us take B derives F. So B derives F. So B closure if you take, okay. So B and B derives F. F derives GH. So GH. So now if you observe the relations, so R1 is going to become, R1 is this one, A, D, E, I, J. And in this primary key is A. R2 is going to become another relation that is B, F, G, H. So this is another relation. So here primary key is B. Now original relation R is what actually? Primary key, of course, AB. Find the attributes which are not covered in any of these two relations. A, B, C is not covered anywhere. D covered, E, F, G, H, I, J. So here, this is what the primary key. Now you see, because the prime attribute is only one attribute, so this is in second normal form. And here also primary key is one attribute. This is also in the second normal form. And here two attributes are there, of course, but A is not deriving C or B is not deriving C, but together deriving C actually, this is also in the second normal form. So that is what first of all we ensured these three tables now in the second normal form. Now we have to go for the third normal form for every table actually again. So now let us check R1. So if you consider only R1 first of all, so R1 if you take, so R1 is covering what are all functional dependencies 1, 2, 3, 4, 5. R1 is covering second FD and fifth FD actually. Okay, so that means you see here A is the primary key. So if you take A, D, E, I, J, primary key is A. So A deriving DE of course and D deriving IJ actually. A deriving D, non-key attribute D deriving non-key attributes IJ. That is what trans2 dependency we have, right? So that means what actually with the fifth FD, we have a trans2 dependency. So find the D closure from the fifth actually. So we are going to have D, I, J. So this is another relation we are going to make it. So R1 further divided like R11 is going to become what actually? Dij, and where D is the primary key. And remaining is what actually? R1. So remaining is what actually? A primary key and D is the foreign key here. And which attribute is not covered? E actually. So that is what. So this is related to R1. Okay. Now let us take the R2 also. So let us consider R2 now. So R2 covering which for FDs actually? R2 covering 3 and 4. So 3 and 4. And here also if you observe, B derives F. So here primary key is B. So B derives F and F derives non-key attributes this one. That means trans2 dependency is there, right? So that is why consider fourth FD and LHS part is F. So F closure we have to find. So F closure is what actually? F and then G, H, it is deriving. So now R2 is becoming what actually? R2 further splitted into R21. So R21 is what? F, G, H. So F is the primary key and original table R2 is what actually? B is the primary key and F is the now foreign key and GH covered here. So that's it. So this is what R2. What about this one? So AB deriving C and C is not deriving anything else. So R is already in the third normal form. So this is already in the third normal form also. So overall the final tables are what actually? So you can see here R1 dash. So that is D, I, J. Primary key is D and R1. So that is A, D, E. And here primary key is A. And next R2 dash, R21. So that is F, G, H. And primary key is F and R2. That is B, F, primary key is F. And original table R. So that is what? A, B, C. Here primary key is AB. Now all of them are in the third normal form. So all these are in a third normal form. So that is what we need, right? We have to split this up to third normal form. So in this way, if anybody told that try to split the table up to third normal form, then first find the key. After finding the key, every FD you check that whether it is a full or partial functional dependency. If any partial functional dependencies are there, for that particular partial functional dependency, LHS part closure find out that make it separate table. For every partial dependency, you do that one and then make them separate tables. And then in the original table, primary key you take and the attributes which are not covered in other tables, you add in the original table. So this is what second normal form. So then go for the third normal form, identify which FDs are covering that particular relation and check that is there any transitive dependency. So as usually transitive dependency, if it is there, then that transitive dependency is LHS part, you find the closure and make it separate table actually. That is what, whenever we are discussing functional dependencies, especially we are finding the closure, we told that this is very, very important. Finding the closure is very, very important. Okay.